This video is a continuation of the last video that is the help for your 3/27 homework and contains problems on sector areas and areas of circles where we're finding the area of a sector where part of that sector or circle is missing. All right, so we're going to go through this first example here. This is a little bit different than the last three problems that I did on the other video. In this case, we are missing this area up here, right here. The area I covered in yellow is missing out of the entire area of a circle. So I'm going to split this up into two different problems. I can see that I have the area of a sector right here, this sector, and I need all of it. So I'm going to calculate the area of that sector, and then I can see I've got the area that I need to add to it of this triangle right here. So I'm going to calculate the area of that triangle, and then I'm going to add the two areas together. So that's a little bit different than what we did in the last three examples where we found the area of a sector, the area of a triangle, and we subtracted them. So let's find the area of the big sector first. Well, I know the interior angle measure of my little triangle here is 120 degrees. So the rest of this is going to be 360 minus 120 degrees. So that's 240 degrees. So when I find the area of this sector, that is going to be 240 degrees over 360 degrees times pi r squared, and r in this case is 7, so that's going to be 7 squared. Well, I know when I reduce 240, the zeros cancel out, and 12 goes into both of those, 2 and 3. So my final sector area is going to be 2 pi over 3 times 49, which is going to be 98 pi over 3. So in the last examples, we looked at finding the area of the triangles. So in this case, we have a nice big 120 degree triangle. This is 120 degrees right here. And when we split it in half, each one of those is going to be 60 degrees. So this will be a 30, 60, 90 triangle with a radius of 7 centimeters. So I know to go from my hypotenuse to my short leg, I divide it by 2. And then to go from my short leg to my long leg, I multiply by radical 3. So I can figure out the height and the base of my triangle. The height of my triangle is 7 halves, and the base of my triangle is 7 radical 3 over 2 plus 7 radical 3 over 2. So the area of my triangle is 1/2 times my height, which is 7 halves, times my base, which is 14 radical 3 over 2. And you can see that 14 over 2 reduces to 7. So when I multiply the numbers on top, I get 49 radical 3. And when I multiply the numbers on the bottom, and remember that 2 is canceled out because I reduced, I get 4. So now I'm going to add these two areas together, the area of the sector plus the area of the triangle, and I get 98 pi over 3 plus 49 radical 3 over 4, and that is my final answer. And if I add my units, that is centimeters squared. So let's try that again with our next example. And again, I'm going to find the area of the sector first. And my triangle has a central angle of 90 degrees, so 360 minus 90 is 270 degrees. So I'm going to find the area of my sector first, so it's 270 degrees over 360, and I'm going to multiply that by pi times r squared, which is 18 squared. All right, so when I reduce, my zeros reduce out, and the largest number that goes into 2736 is 9, so I get 3/4. Let's see, I get 3 pi over 4, and now 18 times 18, I know what that is, but I believe this might be a little bit easier if we reduce this way. I know 2 goes into both 4 and 18, so oops, I get a 9 here and a 2 here, and then a 2 goes into this 9 times. So 9 times 9 is 81. 81 times 3 is 243 pi. So how do I find the area of my right triangle here? Well, I know this is an isosceles right triangle. And so I know this is also 18 feet, which is really nice because we mentioned before that when we have an isosceles right triangle, that's a 45, 45, 90. Our altitude makes a right angle with our base. So 18 is our altitude and 18 is our base. So I don't need to draw anything else or figure out anything else. The area of my triangle is going to be 1/2 times the height times the base, and I can reduce that. So I have an area of 9 times 18, which is 90 plus 72 is 162. And now all I have to do is add these two areas. So when I add my area of my sector to the area of my triangle, I get that. And that is the exact answer, and that will be in feet squared. And then the last example for these types of problems, I have a 60-degree arc measure, so the angle in my triangle will be 60 degrees. So this measure right here, this arc measure, is going to be 360 minus 60, which is 300 degrees. So the area of my sector is going to be 300 degrees over 360 degrees times pi times r squared, which is 12. So I'm going to reduce this fraction here. I'll cross out my common zeros, and I know that 6 goes into both of those 5 times and 6 times. So I'm going to write it like 5, 6 pi times 12 times 12, because I know 6 goes into 12 2 times. So 5 times 2 is 10 times 12 is 120 pi. All right, so now I need to find the area of my triangle. So let's draw this triangle up above here. It's a nice 60-degree triangle. So here's 60 degrees. When I drop an altitude down, I get a nice 30, 60, 90 triangle, and that is 12. I need the height and the base of this triangle. So to go to the short side, I divide that by 2. So I know this part and this part is 6. To go to the long leg, I multiply the short leg by radical 3. So the height of my triangle is 6 radical 3, and the base is the sum of these two numbers. It's 12. So the area for my triangle will be 1/2 times the height times the base of 12. So I'm going to reduce the 2 and the 12 and get 6 times 6 is 36 square root of 3. So now when I add these two areas, I get 120 pi plus 36 radical 3, and that was in meters, so it's meters squared because it's area. Okay, we have one last problem to go over. I'm not going to do all of these because you get the same answer for all of them, and I forgot to color in this part. All right, so how would you do that? Well, this is how I would approach these problems. Each of these problems contains a complete circle, and I'm going to color my circles in with yellow. The first circle is obvious because it is a nice whole circle, and it's easy to do this, to find the complete circle here. In this problem, I have a square, and I am finding the area when I take the square and I get rid of the area of the circle. So that's going to be the area of my square minus the area of the circle. Okay, so how about in the second problem? Well, I have the same thing, because if I put these two circle halves together, I get a nice whole circle. So again, I have the area of the square minus the area of the circle. And if you notice in both of these problems, I have not a radius, but a diameter of 2 feet. This one's obvious, right? This one says the side of my square is 2 feet long. Well, that means this distance here is also 2 feet. So the diameter of this circle is 2 feet. Well, how do I get a whole circle in the next one? Well, this is a quarter of a circle. Here's another quarter of a circle. They both have a radius of 1 foot, and a quarter of a circle and a quarter of a circle. So when I put them all together, I get a whole circle. So the formula for this one is still the area of the square, and I'm going to take away the area of the circle because we're looking for the area of the blue shaded region. So I'm only going to work one of them. So let's go ahead and work. Oh, and by the way, this last one, since this is a radius right here, that's a radius of a circle from the center of the circle all the way to the outside of it, that's a radius. The radius is 1 foot and the radius is 1 foot. The diameter of the circle is 2 feet, just like in all the other ones. So if I work one of these, I will have the same answer for all three. So let's find the area of the square first. Well, I know in the first example, the area of a square is just 2 times 2. It's height times base, and all the sides are the same. So it's 2 times 2, so I get 4. When I compute the area of the circle, I have a formula of pi r squared, and I have to remember that the radius is half the diameter. So I get half of the diameter is 1 foot. So when I square 1, I get an area for my circle of just pi. The area of the blue is the area of the square minus, we're taking out the area of the circle. So I get 4 minus pi, and the dimension is going to be feet squared. And that would be the answer for all three of these types of all three of these problems right here. And that's how you should do them in your homework.